The Ricoh 2A03 and its PAL equivalent, the 2A07, is the custom 8-bit microprocessor at the heart of the NES. While it's based on the popular MOS technology 6502 CPU, it was significantly modified to suit the specific needs of a game console, integrating several key components and removing others. The key properties and specifications of the Ricoh 2A03 begins really with its CPU core, which uses an unlicensed and slightly modified version of the 6502 core, and it has the same instruction set and register set as the 6502, including its 8-bit data bus and 16-bit address bus. The clock speed for the NTSC version, it runs actually at approximately at 1.79 megahertz, while the PAL, or European and Australian version, the 2A07, runs actually at a slower 1.66 megahertz. This difference in clock rate is due actually to the different video refresh rates. The NTSC, or Japanese and North American, at 60 hertz and the PAL at 50 hertz, and affects how the game code and audio are timed. The memory mapped input-output on the 2A03 actually communicates with the PPU, the picture processing unit, and other console components through memory mapped input-output registers, which are special memory addresses that control the hardware. An input-output register is actually a type of hardware register used by a computer's central processing unit to communicate with and control peripheral devices such as graphics cards, sound chips, keyboard, or controller. This includes reading controller input and controlling the PPU's behavior. Now, how did the Ricoh 2A03 differ from the MOS technology 6502? The Ricoh 2A03 is not a direct copy of the 6502. It was specifically designed for the NES, and its differences were crucial for making the console a cost-effective and powerful machine. Firstly, there was no binary coded decimal mode, or BCD mode. This is the most notable functional difference. The 6502 had a BCD mode that could be activated by setting a specific flag, which would make arithmetic operations, that is addition and subtraction, work with decimal numbers instead of binary. This was useful for business applications like calculators, but it was completely unnecessary for game logic. So to avoid patent infringement on this specific feature, which was one of the few patented aspects of the 6502, Ricoh physically cut a few connections on the chip, disabling the BCD, or the binary coded decimal mode functionality. The other aspect which separates the Ricoh 2A03 from the MOS technology 6502 is an important addition, in fact, that the 6502 is just a CPU, and the 2A03, on the other hand, integrates a full audio processing unit, APU, onto the same die. This was a significant cost-saving measure for Nintendo, as it eliminated the need for a separate sound chip. The audio processing unit, or APU, has 22 memory-mapped registers that game code can write to in order to generate sound. So when speaking of the integrated APU, we should first note that the APU is a sophisticated programmable sound generator, and in this case, it has 5 separate channels which allow for complex and rich 8-bit music and sound effects. There are 2 pulse wave channels. These are the most common channels used for melodies and harmonies, and they can produce a square wave with 4 different duty cycles, changing the timbre of the sound. There's one triangle wave channel. This channel is often used for bass lines or smooth melodic tones. And then there's also one noise channel. This channel produces pseudo-random noise and is primarily used for percussion, like hi-hats and snares, and sound effects like explosions or even static. There's also one delta modulation channel, DMC. This channel is a 1-bit sample player. It can play short digitalized sound samples, which was revolutionary for its time, though it was memory intensive and often used for short drum samples or voice clips. Now, the delta modulation channel, I'll end by saying, speaking of the delta modulation channel, which on the Ricoh 2A03's integrated APU is a unique sound channel designed for playing back short digitalized sound samples. So this channel is distinct from the other 4, which produce basic waveforms, for example, the pulse, the triangle, and noise. So the terms that I want to define here are 2, DMC and DPCM. DMC, it stands for Delta Modulation Channel. It is the name of the sound channel itself, one of the 5 channels on the NES's APU. The DPCM now stands for Differential Pulse Code Modulation. This is the specific data compression technique used to encode the sound samples that are played on the DMC. And there is a relationship between the DMC and the DPCM. They work together. The DMC functions by playing back a compressed digital audio sample. Instead of storing the absolute value of each audio sample, DPCM stores only the difference or delta between consecutive samples. So 1-bit encoding is a factor, is a phenomenon here. The NES's DPCM is a very simple form of this. It's a 1-bit system where each bit in the sample data tells the sound channel to either increment or decrement the current output level. A 1 would indicate an increase in the volume, and a 0 would decrease it. Memory efficiency should also be considered here. This method is highly memory efficient. A typical sound sample on other systems would require 8 or 16 bits per sample, but the NES's DPCM only needs 1 bit. This was crucial for a console with very limited cartridge ROM space. The limitations also, while great for saving space, DPCM on the NES has its limitations. It's not suitable for high fidelity music, but it's perfect for short sound effects like voice clips even, such as in A Link to the Past, or percussion samples like the drums in Super Mario Bros. 3. That is all on the DPCM, the DMC, and how those 5 channels on the APU are integrated into the CPU, which we call the Ricoh 2A03, and how it differs from MOS technology 6502.